Okay, you guys. Okay, let's get started. I just wanted to do like a quick example about symmetric group. Let's just try an example like with S4. Let's take sigma to be this 3 cycle in S4, and tau is going to be this transposition also in S4. And let's figure out what is the subgroup H generated by sigma tau. Okay, let's figure out what it is. In particular, one way to do that, well, solution. Let's try and figure out what the relationship between sigma and tau is. Well, of course, first we have sigma cubed is the identity because sigma is a 3 cycle. Tau squared is also the identity. The identity we'll just write like 1 in brackets, meaning it's a kind of the cycle that sends a 1 to 1, 2 to 2, and so on. Tau squared is also the identity. And now to compute in this subgroup, we need to know, is sigma tau, like what's the relationship between sigma tau, tau sigma? Okay. Okay. So what we have to do is we have to figure out like, do sigma and tau, do they commute? Is there some other relationship? Basically, we want to know another way to express this relation, to ask this question is to compute sigma tau, sigma inverse tau inverse, also known as a commutator, which is our next topic anyways. So let's just go ahead and, right. So let's just compute this sigma tau, sigma inverse tau inverse, see what it is, so that we can get information that way. Okay, first let's compute it and then let's see what that tells us. Okay. Sigma tau, sigma inverse, tau inverse. Well, first we have sigma is 1, 2, 3. Tau is 3, 4. Sigma inverse just means, well, sigma goes 1 to 2 to 3 to 1. So sigma inverse just goes 3 to 2 to 1 back to 3. So you can write that like this. And the inverse of any transposition is just the same thing. Okay, so let's try and compute this. Let's try and compute the cycle decomposition of this crazy permutation, right? We start with 1, for example, and we follow 1. So 1, nothing happens. 1 gets sent to 3, 3 gets sent to 4. So 1, if we start with 1, we end up at 4 after we traverse everything. Okay, now if we start from 4, 4 goes to 3 first, 3 goes to 2, and then 2 goes to 3, so 4 goes to 3. Now what happens to 3? 3 goes sent to 4, 4 gets sent to 3, 3 gets sent to 1. Okay. So this is, if we call this alpha, it just tells us that sigma tau, sigma inverse, tau inverse equals alpha. In other words, sigma tau equals alpha tau sigma. Okay, so that can kind of help us compute right? So what is that? What does that help with? So like, for example, how can we compute with this? Well, kind of only helps if alpha, if we know like some information about alpha, basically. Okay, so kind of like, let's try and record some information. We know sigma, we know alpha cubed is the identity. Okay, so let's try and think up, like, let's try and figure out what what the subgroup H is. Like, what do you get if you combine sigma and tau together in all different ways? You know, like for example, is it possible, like, is it possible to get like do you get all the different 3 cycles? You know, do you get all the different, right? So let's take alpha and combine it with sigma and tau. Let's try and do like, what is alpha tau, alpha inverse, tau inverse, just for example, what do you get? This as an example, what do you get? Well, you get, start from 1, 1 gets sent to 3, 3 to 4, 4 to 3. And then what about 3 gets sent to 4, 4 to 1, 1 to 4. What about 4? 4 gets sent to 3, 3 back to 4, 4 to 3, 3 to 1, right? Does this 3 cycle, 1, 3, 4. In other words, this is the same. This is alpha inverse. Oops, 3, 4, 1. Right? I hope I computed everything correctly. 1 to 3 to 4 to 3, 3 to 4 to 1 to 4, and 4 back to 1. Okay. So what does this tell us? Alpha tau equals alpha inverse tau alpha. In other words, alpha squared tau equals tau alpha. So now inside H, this is useful. Inside H, we have the subgroup K generated by tau alpha, satisfying alpha cubed is, and alpha squared tau is tau alpha. So sitting inside H, we have this subgroup, which is isomorphic. If you remember, this is the subgroup D3. Okay, and that can help us compute the subgroup H, so it has 6 elements. Now, if you what you can actually show, I think you can show is normal in H, and H mod K H mod K is just what should that be? This, let's think about what that should be. So let's first establish that K is normal in H, right? So we need to check. Oops, we need to check that sigma K, sigma inverse is a subset of K. Why do we need to check that? And not anything else? So let's just remember H is generated by sigma and tau. K is generated by alpha and tau. Okay. So let's try and, what does that mean? Let's suppose sigma K, sigma inverse is contained in K. Now tau is in K, so of course tau K, tau inverse is also in K. So if we show this and we know this, now anything in H is like some combinations of sigma and tau, right? So let's write down an element of H. Might be something like sigma squared tau, sigma inverse tau sigma, some combinations of sigmas and taus. And now if we do that, let's call this G, then G, K, G inverse is just sigma inverse tau, sigma times K, and then sigma inverse sigma, tau inverse sigma to the -2. Here, this is just the inverse of this element. Okay, now our assumption is that, well, the next thing we're going to show is that sigma K, sigma inverse is contained in K. So this is a subset of sigma squared, sigma inverse tau. And now sigma K, sigma inverse, we can replace with K. And now tau K, tau inverse, that's also K because tau is an element of K. Right, now sigma inverse sigma, that's also sigma inverse K sigma is also K by this assumption. And you can see how everything just collapses. This is also K. Well, this is just sigma, sigma, K, sigma inverse, sigma inverse. So this is K, which is K, okay? So as long as I check that my group K, when I conjugate, as long as I can conjugate by the generators of H and I get K back, that will mean that K is normal in H, okay? So now let's check what is sigma K sigma inverse. Well, it's just generated by sigma alpha sigma inverse and sigma tau sigma inverse. Okay. Of course, sigma tau sigma inverse, tau inverse, that's just alpha tau, which is in K. K is generated by alpha and tau. Okay, so I need to just now check that sigma alpha sigma inverse is also in K. Okay, what's sigma alpha sigma inverse? Right, well, alpha is just something like alpha is just this thing, sigma tau, sigma inverse, tau inverse. Okay, how does that help us? Well, let's think about it for a little bit. Well, can write this, so you have sigma squared tau, sigma inverse, tau inverse, sigma inverse. But in fact, like we have to use the relation Remember that sigma is a 3 cycle, so sigma cubed is the identity. That means sigma squared is really sigma inverse. And sigma inverse is really sigma squared. Okay. And now so now something tricky is gonna happen, I guess. Well, that's just sigma inverse tau sigma times sigma tau inverse sigma times sigma. Or wait, I can write the sigma squared as sigma to the minus sigma squared. Let's leave this as sigma inverse. Okay. Let's unravel everything a little bit. We have sigma inverse tau, sigma tau inverse sigma inverse. This is another way to write, this is alpha tau. And this is something related. So you have like sigma tau, sigma inverse tau inverse equals alpha. So sigma inverse alpha. Oh, sorry. So if you do oh yeah, so if you do sigma, okay, sorry. If you try and relate it to this, you multiply on the left by sigma inverse and tau inverse. You get sigma inverse tau inverse equals tau inverse sigma inverse alpha. Somehow you got to be able to relate it back to, oh, I have a question. Not surprising because I have some questions as well. Oh, can you see the top of the page? It's a long page, but okay. Okay. I think maybe what I want to do is, I mean, kind of the goal is to show like, write this in terms of alpha and tau. So what I want to do is stop this example here and write it up nicely for you in a video. So that everything can be wrapped up neatly in a bow, I guess. Okay, I hope that would be okay. And then next week, we will start in on kind of the basics, these things called commutators, which tell us like how far off, like, which tell us about if two elements commute or not. Okay. So, sorry for this example, which kind of got off track, but I will definitely have a video for you to kind of neatly explain everything. Yeah, okay. Okay, I guess that's it. If you made it this far, thank you for listening. Okay. Oh yes, and recordings, I will put them up as soon as they're done. Okay. If you have any questions about the assignment, just send me an email. Okay. Yep, that's it. Okay, have a good weekend, everyone.